Thank you for choosing to view this video clip. Its purpose is to give you an overview of the challenges that students will face in working with the tools of modern science. These tools are evolving continuously and becoming more widely accepted as the benefits to improving laboratory operations become evident. This applies to all sciences, including chemistry, clinical work, physics, biology, mathematics, as well as engineering. Science has continued to advance as new fields and areas of work have developed at an increasing rate. New technologies are opening up new areas of study. The most dramatic changes in laboratory work can be found in the tools and methods used to carry out research and development, as well as testing in industrial and healthcare applications. Robotics provide better and faster methods of preparing samples for analysis and evaluation. Paper laboratory notebooks are being replaced with electronic versions that offer better documentation of experiments, searching, archiving, collaboration, and management of intellectual property. Laboratory information management systems, also referred to as LIMS, provide an electronic mechanism for managing laboratory workloads and workflow in quality control and testing laboratories in a variety of industries and laboratory settings. These systems provide a means of tracking samples throughout the testing process, from login, generating work lists, entering test results, and having them reviewed and approved, and then finally reporting the data. Laboratory instrumentation has changed dramatically. The photo shown here is that of a chromatograph, one of the most widely used instrumental techniques. The manually operated instrument, with the initial data recorded on strip charts and processed by manual calculations, has given way to automated equipment that handles the samples, manages the instrument, and then captures and analyzes the data using an instrument data system. While the technology is rapidly developing, the technical capability of those working in labs, and in particular those coming into the field, has not kept up. This statement from American Laboratory reads, "Even today, the instruments are often more sophisticated than the average user, whether he or she is a technician, graduate student, scientist, or principal investigator using chromatography as part of the project." And that citation isn't alone. From a 2005 article, we can see, despite a lot of exposure to computerized data handling, however, many practicing chromatographers do not have a good idea of how a stored chromatogram file, a set of data points arrayed in time, gets translated into a set of peaks. These are pipettes widely used in laboratory work. Older versions are on the left, and modern units are on the right. This article, published in 2011, talks about their use. The comments on the screen are the author's impression of the state of education in modern technologies, where he says, "My response is that lab automation is a sorely needed program at the university level. Can you imagine, I was on a campus tour this summer where a junior biology student had no idea what a multipipetter looked like, let alone an electronic version or a workstation. In big pharma, multi-well plates are more common than conical or Eppendorf tubes." Once optional, lab automation technologies are widely used to improve lab productivity and effectiveness, improve product quality, reduce costs, improve safety and working conditions, meet the needs of regulatory agencies, improve intellectual property management, and meet the need for collaboration in scientific work. All of this is driven by increasing workloads, staff and budget cuts, the use of outsourcing, and the increasing complexity of the science. About 3 years ago, we did a review of the job requirements published by companies looking for employees in laboratory applications. These included both management and non-management positions. The chart on the screen shows the types of requirements that were being looked for. Note the very low percentage of technical requirements. This is completely inadequate for modern laboratory work. In a survey done by the Institute and the Lab Managers Association about the qualifications needed to work in modern laboratories, we found that in most companies' dependence on laboratory automation has changed the skill requirements to be successful in laboratory work. The survey showed that lab automation is essential for most laboratories, that the skill set necessary to work in automation has changed significantly, that entry-level scientists are generally capable of working with laboratory hardware and software, that is, people with master's degrees and above, but people at the bachelor's levels often are not. And most telling, in general, applicants for positions are not well qualified to work with automation. The chart on the left shows the response to the statement, "Staff qualifications are a concern in deploying laboratory automation technologies." The majority of the respondents strongly agreed, or just agreed, with that statement. The bottom line is simple. We need better trained people coming out of schools to meet the needs of scientific industries. The background on the screen shows a grid whose bottom axis is time beginning in 1970, and whose vertical axis shows 5 key laboratory functions: document management, experiment execution, record keeping, sample tracking, and instrument data capture. Now we'll map out the development of 4 key technologies, 3 we've noted in this presentation. The fourth is scientific data management systems, used for managing lab data files. Notice when the different technologies appear on the chart and how rapidly they expand their complexity. These technologies are not used in isolation, but often in combination, each meeting particular needs. One goal, yet to be realized, is the integration of products to smooth the flow of information. Understanding what these technologies are, how they contribute to lab operations, what they are or are not capable of, is essential to your students' success in laboratory work. Not only do people need to be better educated when they come out of school, they need access to continued, ongoing educational programs to keep up with new technologies. There are few, if any, well-organized courses in the field of laboratory automation, informatics, and computing. Most educational programs are provided by vendors, usually product or technology specific, centering on their commercial interests. On-the-job training, which due to time constraints is usually limited to what is needed to get a task done, avoiding the underlying theory of the technologies. It stresses what to do mechanics rather than understanding, at least in the short term. And finally, conference short courses, some provided by vendors, some by industry experts, but only available at the meetings with no long-term coordinated program. Education is not just for laboratory professionals, but for those who support their work as well. The increasing reliance on information technology means that IT professionals need to understand how lab systems are used and how to support them. In particular, they need to understand the regulatory environment to ensure that regulations and standards are met. The education we provide will help IT and lab professionals work together and relieve a common and persistent problem in the industry. The ILA's programs provide a basis for understanding and applying advanced laboratory technologies to laboratory problems. Ask us how they can be put to use as part of your programs, and how they can make your students more competitive in today's job market. Thank you for taking the time to view this presentation. We need to work together to improve the capabilities of those working in and supporting laboratory operations. Improvements in their ability to carry out research and development work is important to them, to you, your school's programs, and to the scientific community as a whole.